Hello and welcome back. Today we're going to be covering collisions and how to get the code set up for that in our game. Currently, I have my little tank here. It can successfully turn around, move just fine, as we've done in class before. But we have all coded in different movement mechanics. And so I was going to address how to address collisions for both sets of mechanics. So I have a collision setup or movement style where I can only move forward or backwards. This, of course, means I need to just address collisions in my front and rear. However, this collision is relative to the angle that I'm looking at, which makes it a little bit more complicated. On the other hand, the Goliath I have over here needs to address collisions in regards to just absolute movement because it can move left, right, up, and down without any issue. So we're going to go ahead and see how to program collisions so that way our Goliath can properly be stopped in all cases. So let's go ahead and jump into our code. So again, my Goliath is going to represent your player object. I have it set up both ways. If you're using the key events to address moving in a specific direction, you need to make sure you implement the code for all directions. In this case, I'm going to show how to stop yourself from moving left into a particular object. In our case, I'm using the wall as the object that we collide into. So if we have an instance at a place x plus length. Oh, no, this is just x. An instant. Let me minimize this. If we find an instance, we're looking for something at a particular location. Our current x and y values at this specific spot, and we're looking for a wall in this location. Let me increase the there we go, text size for y'all. So if at this x value and this y value, let me actually break it off into segments just to make it easier to read. Okay. Closing off the if statement, open it up, and then everything inside here goes there and capture it back here. But if I'm moving towards the left, I don't want to be checking. Technically, what this does is it places our object at this location and checks to see, do we collide with this thing? Well, our x and y is where we currently are. So if we're colliding with it, then we have already run into it. I want this to be a little bit more forward facing. So if we were moving in steps of 4, if I move to the left by 4 pixels, do I collide? That way, if I collide, I don't want anything to happen. If I don't collide, I want us to do this. So how do I say not collide? Well, I can actually just say not instance at this location. So if we are not going to be colliding with a wall at x minus 4, x minus the movement step we're doing, and y, my current y value, then and only then am I allowed to move. So let's go ahead and test this out to see if this properly addresses left collisions. So let me move my thing over. Can I collide into the left? Nope, it stops it. We've got that working. We don't, however, address top, nor do we address right. So let's go ahead and look into addressing those two sides. Again, it's going to follow the exact same format. We just slightly change a few things. For our key down, I had the step being 5. Again, I'm just putting these in as arbitrary numbers. Again, this is plus 5 because to move to the right, it is positive in the x direction. And then for moving, which one is up? Up is key 8. address this, but for our y value to move up is minus, I think I had 5 before. And again, we address it for our y minus 5. We're looking 5 pixels above us. So I'm about to move up 5 pixels. If I moved up 5 pixels, would I collide with this wall? If the answer is yes, don't let us move up 5 pixels. Again, this references our origin. So if your origin is in the center, then this should be okay. However, if your origin is off center, you might have to, no, this should work in all cases because it just moves your image exactly there. So it doesn't matter the location of your origin. You should be fine. Yeah. And then the object is whatever we're running into. This will address collisions in the absolute movement of left, right, up, down. If we put this in place, I can't move down into this wall. I cannot move right into this wall. I cannot move up into this wall, nor can I move left into this wall. So it appears everything is working correctly and everything looks pretty nice. Now, some of you chose to have collisions similar to how my tank, or movement similar to how my tank operates, where you only move forward or backwards. To address that code is a little bit more effort. And so let's go ahead and look again in my Goliath. I wrote a simplified version of how I move. So originally, let me simplify this to what it was before. Let's see. There you go. So at the start, this was our program. If I press T, I move forward. It sets the motion based off of our image angle. If I'm not pressing T, it brings us to a halt immediately. But how can I confirm or check if I'm going to collide into something to stop this? Well, we use the same function, but we're going to have to use this. You might have done this in a key down event, wherever you put it. I'm just addressing it here. You will need a conditional. If it's a key down, then let me demonstrate what that would look like in a bit. But first, addressing it if you wrote it as a step of it. If I press the T key, I move forward. If not, stop. So if I press the T key and I'm not going to collide into, let me shift this, and not going to collide into instance underscore place of, again, X value, Y value, and O wall. Let me make sure. I think I'm seeing a parentheses. Yeah, extra parentheses to close it off. Yes, there we go. But I'm moving not directly forward or up, down, left, right. This is based off the angle I'm looking at, so I have to do a little bit of trigonometry. Or we can use the wonderful functions created for us, length on dir underscore x. This will do the math for us. In this case, I'm moving 5 pixels in the forward direction, whatever that is. Well, this will calculate based off of what our forward direction is, our angle, what the correct amount to add to x is. Same thing, length dir underscore y, 5 pixels at this image underscore angle. And it correctly adds to our y value, the correct amount based off of what angle we're looking at. And so that way it can calculate where we would collide with the wall. Then let's run it to confirm it still works. So long as we're not colliding, then we're good to go. And so for me, T is forward. So let me actually set myself up here. T, yep, I can't collide in here. It runs into this, it detects it. Otherwise, I get to keep moving. And that's just how that is built. If you did it in the step event, oh, this is canceling it out. Because we're not pressing T, it cancels it out. So technically, I guess you can't really do this unless you have it in the step event. In which case you'd have to make sure it is in your step event, because it would actually be an if, else, if, and then else block. Now, when we run it, it'll equally check it for the rear movements and prevent us from crashing into it. And so let me position myself correctly, and then T moves forward, G stops it. Again, it detects the collision and prevents us from moving into it. And there you go. That's how you can address collisions with a wall, by either doing it using the forward and rear movement or doing absolute movement in respect to up, down, left, right. So if you have any questions about this, just let me know in class. Otherwise, that's all I've got for y'all today. Everyone have a good one, stay safe, and I will see y'all next time.